Say anytime you're talking to your phone, it's pretty much a neural net doing that. It does really well in image recognition. Autonomous cars coming soon. The top flight method for genetic sequencing is a neural network. You can say they're loosely inspired by the brain. It is a network of neurons, people call it neurons. And they're all connected to each other, going down through the layers. In a way, they mimic neurons in that they're little triggers. Each neuron has kind of a threshold called a weight where it makes a decision. So it takes in data, it could be a huge amount of images. And then once the network is trained, you can put one image in at the front. They fire when they see the thing that they want to see. So you have this kind of cascade moving through the neural network. And that does really poorly, it just does horribly. But there's this little magic trick called backpropagation. And this is very unbiological. Your neurons don't do this at all. But at the end, you're like, okay, well, you were wrong, but here's a proper picture of a dog. And now you send all that information back through the network again. And the network learns just a little bit better how to say, oh, this is a dog. It's elegant math, and really the breakthroughs in the field were when they stopped trying to be so biological in the 1980s. At the time, they didn't work that great, but it turned out all they needed was a huge amount of processing power and a huge amount of examples, and they would really sing. So in many of these cases, accuracy is enough. But when you're talking really life and death decisions, driving an autonomous car, making medical diagnoses, or pushing the frontiers of science to understand why a discovery was made, you really need to know what the AI is thinking, not just what its results are. Since you have all these layers, it just engages in such complex decision making that it just is essentially a black box. We don't really understand how they think. All is not lost with this black box problem. People are actually trying to solve this now through a variety of different ways. One researcher has created a toolkit to get at the activation of individual neurons in a neural network. This toolkit works by taking this individual neuron and telling the network to go back and find all the weights that really make that neuron just fire like crazy. Keep doing this thousands of times and you can see the kind of perfect input for this neuron. Then looking inside these layers, you could see that some neurons learn these really complex, abstract ideas like a face detector, something that can detect any human face no matter what it looks like. This is not a property you would expect an individual neuron to have, and most don't, but some do. Many neural net researchers think of it this way. You can think of the decision making of a neural net as this kind of terrain of valleys and peaks, and the ball represents this piece of data so you can understand this one decision that was made in one valley, but all those other valleys, you have no idea what's going on. So one way to get at what an AI is thinking is to find a proxy for what it's thinking. So one professor has taken the video game Frogger and trained an AI to play the game extremely well, because that's fairly easy to do now. But what is it deciding to do? It's really hard to know, especially in a sequence of decisions and a dynamic environment of that. So rather than trying to get the AI itself to explain itself, he asked people to play the video game and had them say what they were doing as they were playing it, and recorded the state of the frog at the same time. And then he found a way to use neural networks to translate those two languages, the code of the game and what they were saying. And then he imported that back to the game playing network. So then the network was armed with these human insights. So as the frog is waiting for a car to go by, it'll say, oh, I'm waiting for a hole to open up before I go. Or it could get stuck on the side of the screen and it would say, geez, this is really hard, and curse. So it's kind of lashing human decision making onto this network with more deep networks. It's all about trust. If you have a result and you don't understand why it made that decision, how can you really advance in your research? You really need to know that there's not some spurious detail that's throwing things all off. But these models are just getting larger and more complex. And I don't think anyone thinks they'll get to a global understanding of what a neural network is thinking anytime soon. But if we can get a sliver of this understanding, science can really push forward and these neural networks can really play.